Hello AP Statistics class. So this first video on Chapter 10 is intended to introduce you to the concept of re-expression of scatterplots and linear regression models in order to make them straight. So we're going to be looking at the variety of functions that are traditionally used to re-express data in the attempt to make it straight and so you can fit it with a linear regression model. This video is also intended, besides to review working with some of these Algebra 2 functions, for those students who might be in the class who have not encountered those functions yet, or who don't have hardly any experience if they're taking Algebra 2 concurrently. So let's have a look. By the end of the video, I want to be able to use the three re-expressed models on the top to make predictions. So basically this is all about the mathematical mechanics of solving for one variable using these models. It's not about how to select the models. That's what we're going to be working with in other videos and continue into next week. So first I wanted to talk about the traditional functions. These are not the only functions, but they're the typical ones that you'll see re-expressed data in AP Statistics and in pretty much every science class in college where you need to work with scatterplots. Very common. So traditional functions used to re-express bivariate data, I didn't put these in any particular order. We're going to learn about a ladder which has an order to these functions next week. So sometimes you'll just see the data being squared. Now I've written these all in terms of x, but sometimes we're going to mess with the x, re-express it. Sometimes we're going to leave it alone and square the y's. Sometimes we're going to just square both the x's and the y's. So that's an option. You can see in my models up here I've only modified one variable for each. I've taken the logarithm base 10. If there's not a number here, that means base 10. So I've taken the logarithm base 10 of the y hat here, so of the y variable, the response variable. And I've left x alone. In the second model, I've left the response variable alone, but I've taken the square root of the explanatory variable in order to try to straighten the scatter plot. In this one, I've left the x alone, but I've divided by the response variable, the y hat. So I've messed with one variable in each. It's very common to, in fact, change the x and the y. We'll look at one of those too. But anyway, these are the different kinds of functions. So some of you, if you've not finished Algebra 2 yet, might not recognize these. You should at least have seen the exponentials, but you haven't done very much with them yet. You haven't seen logarithms. Logarithms are in fact the inverse of exponentials, so don't get intimidated. We're just going to be solving equations with them, so you don't need a lot of knowledge. And 1 over x, you haven't seen it either, but you've seen square root and x squared. So these functions are all from our library of functions. They all have a certain look. You should know their look unless you haven't finished Algebra 2 yet. But you don't need to know their look to work with them in this class. Mainly, you just need to know how to solve equations with them. And these are the kinds of equations you're going to be solving. Modifications on mx plus b. That's it. So let's look at plugging some things into these models and solving for the other. Before we do that, though, I want to mention which ones go with which. Remember, to get rid of square roots, you use its partner, x squared. Move over. To get rid of 1 over x, you multiply by x. That's the inverse operation. To get rid of logarithm, logarithm is the thing that gets rid of exponential functions. So you use exponential functions to get rid of it. I'll demonstrate in a second. This is also a logarithm. In fact, natural log of x is just a special logarithm, which you'll see a lot in this class. It's logarithm base e. And if you remember from Algebra 2 or haven't seen it yet, that's okay. E is just a special number like pi that's approximately 2.718. So a here means any base, so I'm just thinking exponentials like base 2, and e is the exponential base 2.718. So partners here are x squared and root x. You just multiply by x here, so it doesn't have a real interesting partner. This guy's partner is here, and logarithm base 10's partner is the exponential, 10 to the power of x. So let's look at plugging some things into these models and solving, because that's all you're really going to need to be able to do, besides picking which re-expression is best, which we're going to be working on for over a week. This first few problems in your assignment for Chapter 10 is mainly about using the re-expression that the book has chosen and solving with it. So suppose we were supposed to predict y for this problem. And let's say they gave us x was equal to 4. So to make that prediction, I would say, okay, just plug it in. The logarithm of y hat is equal to 13.62 times 4 minus 1.74. I'd get that number with my calculator. Let's see. So it's about 53. And that's equal to the logarithm of y hat. Now, of course, I don't want the logarithm of y hat if I'm solving a problem. I want y hat. I want what the y value is. So to get rid of the logarithm, I said a second ago, its partner is exponential. To get rid of logarithms, you apply the exponential on both sides. This is base 10 if it doesn't have a number there. So I apply base 10 to both sides. I'm not multiplying by 10. I'm raising each side to 10. That's what allows you to cancel the logarithm and get y hat. So you just got to go 10 to the 53.14 over here. And I'm going to say, I'm not even going to feed that to my calculator. That's a huge number. I just picked this out of nowhere. So pretty unreasonable. You won't have that happen in your problems, I don't think, except on a couple next week where we work with planetary measurements. That's just such a huge number. I bet the calculator can't even do it. Let's try. I don't think so. I think it's going to say overflow. Oh, I was wrong. It's something to the 53rd power, which makes sense, right? That's just a power of 10. So it's a really huge number. Okay, let's use that and make one more prediction. So what if they gave us a value of y, like 1,000, and they wanted you to say what x went with that y? Well, just plug it in again. Don't make it harder than it is. So you're going to say the logarithm base 10 of 1,000. It's like sticking it into the logarithm. You can put parentheses here if you like. And you solve for x. This guy you can stick in your calculator. There is a log button in your calculator, but those of you who've had Algebra 2 or a higher class should know 10 raised to what power is 1,000? Your calculator is going to tell you 3. That's how logarithms work for those that are unacquainted, but you can just use your calculator. Alright, so now we're solving for x, so I'm going to add 1.74 to both sides, so that's what, 4.74 equals 13.62 times x, and divide, use our calculator for that. And we get that the x that goes with the y of 1,000 for this problem is 0.348. I'd of course always want to specify units. Make sure you don't leave out your units. We don't have units on these problems. We're just doing the math. Okay, so there's using that model that has the y modified by a logarithm. This one has the x modified by a square root. So let's say they give us x is, I don't know, 17. Well, pretty easy. Plug it in. You're going to get y hat equals 12 plus 2 roots of 17. 17 doesn't have a nice even square root. It's a little more than 4, so I'll use my calculator. And we get about 20.246. Again, I'd want to put units of the y variable. So that's one prediction. Let's use this model one more time. So if they gave us an x, that's how you do it. What if they gave us a y, I don't know, 112. So I'm going to stick that in to y. So I've got 112 equals 12 plus 2 roots of x. I'm going to subtract 12 on both sides. It's going to be 100 equals 2 roots of x. I'm going to divide by 2. That's going to be 50. Equals square root of x, and what's the inverse of square root? How do you get rid of it? You square both sides. So you're going to get 50 squared, so that gives you x is 2,500. Stick your units on there, and there you go. So you can see how easy it is to solve most equations with these models. I'm mainly just doing this for those who haven't done a lot of Algebra 2 in a while, or who haven't taken the class fully in. Let's use this model. So this time, I'm going over here. Let's say we have x equals, I don't know, maybe it makes sense to put negative numbers into this one. Maybe it's temperatures or something. So we're going to get 1 over y hat equals 7 times negative 2 plus 8.39. So it's going to be negative 14 equals 1 over y hat this time. So stick that in your calculator. Get negative 5.61. And you don't want 1 over y hat, you want y hat. So how do you get it by itself? I think this is a pretty simple little thing. Even Algebra 1 students should kind of know by the end of the year. To get y hat by itself, well, you need to multiply it on both sides, so it basically moves up there. That cancels it out here, so you get 1 equals negative 5.61 y hat, and you divide by that number to get y hat. So we're going to get 1 divided by negative 5.61. It's going to be negative 0 point something. Yep, 178. So there's that prediction. Let's take that same model and plug something else in. I plugged x in, let's plug y in. So let's say we have y equals 3. We're going to get 1/3 equals 7x plus 8.39. That's a number, so I'm going to combine it with that number, like terms. So I'm going to, actually, you know what? I'm going to solve for x, right? Let's move this one this way. So we're going to have 7x equals 1/3 minus that. That's going to be like negative 8.0 something, right? Let's get a little more precise though. 1/3. Oh, I should always follow my rule and wrap fractions in parentheses, just in case. Doesn't matter this time, but I don't know how much experience you guys have with fractions. 0.57. And we need to divide by 7. We'll have our answer. So we should get negative 1 something. Yep. Stick your units on, and you're good to go. Let's do one last model that has transformations or re-expressions on the x and the y. So let's say we have a model where you have y squared. You know, let's do another logarithm example for those Algebra 2 people. So let's say we have the natural log of y hat equals the natural log of x. So let's say we have 2 natural log of x. Here we go. Let's go 2 natural log of x minus 7.8. Okay? So we've got a transformation or re-expression on the x and the y. So first let's stick in x equals 4 and predict the y. So I'm going to get the natural log of y hat equals 2 natural log of 4 minus 7.81. This is all just a number. You can use your calculator to crank it out. Let's do that. We'll say it's approximate. Yeah, you can grab your thing, Gabe, if you need it. All right. And now we need y hat. We don't want the natural log of y hat. We want the actual y for our prediction. So how do you get rid of logarithm? The first example I did a moment ago said use the exponential. That's its inverse. That's how you get squared is the inverse of square root. Exponential is the inverse of logarithm. A moment ago I also said the base of natural log is e, so I apply the exponential base e to both sides. Once again, I'm not multiplying. Multiplying gets rid of division. Exponentialing gets rid of logarithms. That's what cancels here. So I get y hat equals e to the negative 5 power. So that's going to be about what? We use our calculator to get it. There's an e button on your calculator on the right. So raise it to that power. And our prediction for this one is 0.0064. Let's do one last one. So that was with an x. Let's stick in a y. So what if we have y equals, I don't know, let's say e squared for some reason. Probably not, you're usually going to just have a number, but I'm just doing the math today. So if we have y equals e squared, then I'm going to get the natural log of e squared equals this stuff. Now, you can put this in your calculator, especially if you haven't finished Algebra 2. But natural log and e are actually inverses of each other. If you put an exponential inside a logarithm, just like if you did it the other way around, they cancel. So your calculator in this case is going to tell you 2. And now we just need to solve for x. So I'm going to add. So what's that going to be? 9.81. I'm going to divide. So it's going to be what? 4.9 something. Let's use our calculator. .905. And once again, how do I get rid of logarithms? Use the inverse function, which is exponential. The exponential that goes with natural log is base e. That cancels here. So you get x is e to the 4.905 power. Which is going to be a pretty big number, I think. So there we go. There's our last prediction. So I'm going to talk more about how to actually judge what kind of re-expression you need in the next video. So you want to move on to that now if you're watching this in Thursday's class. Otherwise, I'll see you next time.